Yep. Hello, good evening all. Can you hear me? You can do a thumbs up or...
Yes,
Yep.
Vikas, we can.
Oh, cool. Thank you.
Yeah, Vikas, we can hear you.
Thank you. Thank you. Good evening, everybody. Welcome to Software Test Automation Group Meetup. Today, we have a very renowned professor from Monash University. She is Dr. Aldeida, and she comes with a very strong background in IT. And I've had a few conversations in recent times with her. And then she's very passionate about software testing and artificial intelligence. And then this is the need of the hour, as everybody can assess that artificial intelligence is going places. And then we should not be left out, those who are in the testing space. So today, I'll have Aldeida speak to us about testing AI systems, which is going to be very, very intricate in coming days. So Aldeida, please give us a brief intro about yourself and walk us through today's topic. Over to you, Aldeida.
Great. Thank you, Vikas.
I think you can mute yourself.
I did. Can you hear me? You can hear me online? Yes.
I'll just make one quick announcement. Sorry, guys. If you have any questions, please feel free to raise your hand or put it in the chat box, and or either you can unmute you and then you can pose your questions, or we can take the question answers in the end. So, yeah, that's it for now. Thank you. Over to you. Sorry.
Great. Thank you, Vikas, and thank you for the very kind introduction. And it's really nice to be here. And it's really interesting to hear of the different backgrounds, and that's great that you are interested in software testing, because often that's seen as a boring area and it doesn't have that excitement as other areas. But for me, it's always been
involved in military avionics, in defense, you go and do it.
Yeah, absolutely. So I've always been very passionate about testing. So it's really great to be among a group of people that find testing interesting. And I think it's becoming even more and more important now with AI systems and generative AI. Testing is now very fundamental for these systems to go into production. So it's a very exciting area, both not just from the point of view of research, but also industry. And there's so many interesting problems that we still need to solve. So today I think I have more slides than there is time, so I might skip some of the slides, but also I might change where the talk goes depending on questions as well. So please interrupt me if there is anything that you find really interesting. I might dive deeper into that particular topic and then skip the others. So I really want this talk to be very interactive. As Vikas mentioned, my talk will be about testing generative AI systems. And I've put Gen in brackets there because I want to touch also on AI systems as well. And generative AI is the sort of latest hype, and it's makes testing even harder of this kind of systems. But I might touch also during my talk on the topic of testing AI systems as well. And so I'm going to talk about what are some of the challenges of testing such systems. I'm going to also give you some, I have a few slides around some of the work that we're doing to address some of the challenges. And I welcome, of course, if you are interested in any of these, I welcome, please write, get in touch with me through LinkedIn or email. So my email would be aldeida.aleti@monash.edu, and be happy to discuss any of these further with you. Okay, I probably don't need to tell you what AI systems are, but I put this slide just to set up the context, because we talk about AI and AI models, and what do we mean when we say AI systems? The difference is, well, an AI model is perhaps just a small component of the whole system. There are other components and other software that we need to build that are not about the model itself, but it needs to support the model, such as data engineering and other different components. And I've put here some examples of AI systems that we see, and often we don't realize that there's an AI in the back end. And for example, we have commerce systems where AI is used to predict. Hello. That's okay. So AI is used to recommend the best next product for a particular customer. We have fraud detection. AI is being used now for medical diagnosis, or also is used in robotics. So self-driving cars. So it's becoming more and more prevalent in everyday applications. In particular, Gen AI is what the hype is about at the moment. And there's been trillions of dollars spent in infrastructure to build these Gen AI systems. But the hype is yet to match reality. Billions are being spent to build proof of concepts by industry that are failing to reach production. Often there is like more than 12 proof of concepts that are built one after each other without any of them making it to production. The reason why it is so hard to deploy these generative AI systems is because they present some unique unsolved challenges that traditional software systems don't have. And one of the crucial aspects, and probably it's not the only one, but crucial aspects to actually make these proof of concepts, to successfully deploy these proof of concepts, is quality assurance. And part of quality assurance, of course, it's testing. So how do we test that they are ready for production, they are of the quality that's needed, they are not biased, and so on. So I'll touch on some of these points in my next slides. So why don't these Gen AI systems make proof of concepts make into production? I mentioned testing and debugging, which is one of the key things, but we also have issues around data. So data quality, because these generative AI systems, they are trained on data, and if the data is not of the right quality, then these proof of concepts will not work. Infrastructure is another issue. AI skills, adoption, acceptance by people that these systems are actually safe and reliable. These are some of the issues, but the most important one, in my view, and what I'm going to focus on, is the testing and the debugging. So testing is important because it, in particular for generative AI, and I'm not sure if much you know about generative AI, but things like fine-tuning. Have you, can I ask how many of you know what fine-tuning means? So maybe I'll focus a little bit on that aspect, although it's not a critical one, but it's an important one. So we have these large language models that are being trained on the whole internet, and they are for general purpose. You ask a question, it gives you an answer. But to make them work in a particular context well, for example, to make them work for coding tasks, so you want a generative AI system to help you code, you ask, for example, you give it a specification and it creates a code, or you give a code, it creates a test case. So to use them for particular purpose, fine-tuning is important. Fine-tuning means once you train a model, which is very expensive, then you can take it and you can do a refining process that is just adjust the weights by using data that is specific to a particular problem. It's not a full training, it's more you fine-tune the weights and you make it work for a particular purpose. So fine-tuning is often what people do. Training is very expensive, in particular in Australia. We don't have the infrastructure often, in particular even in universities. We do have we do have some resources, but they're not enough to actually train full models. And even with talking to some banks, even they, to train those particular models for their particular purpose, they don't have the infrastructure in Australia. Although that infrastructure is being built, but it's not there yet. So fine-tuning is one of those things that we need to do. And so when should we fine-tune? So to make those kind of decisions, we need testing, because testing can tell us where this particular Gen AI system or model is working and where it's not working. When should I prompt? And prompt, I guess prompting is a concept that I think we're familiar with. Testing can tell us when should we prompt and how should we prompt, and whether those particular prompts work well or not. Testing also tells us in what ways will the model hallucinate, and we know the problem of hallucinations, right? I mean, these generative AI models are prone to hallucination. And one of the, I guess, hallucination, I guess, means it gives us the incorrect answer. You ask it, for example, what's the capital? Well, often it won't hallucinate for that. What's the capital of France?
So
because
hallucinate.
So the concept of hallucination is related to, I guess, if you've used ChatGPT, you ask it a question, and sometimes it gives you the right answer. Sometimes it completely gives you the complete wrong answer. And so that's called hallucination. And it depends, I guess, on different factors. It depends on the initialization of that model. So if you've asked particular questions before that question, it sets the model in a particular state, and then the model then starts to hallucinate. And the reason why it hallucinates is because the way these models work, they work on that concept of next token prediction. So if I next think of a sentence, and I feel like I'm going in a direction that's not related to testing, but I'll change this soon. So you give it a sentence, for example. So the way it works is when you put a question in there, it looks at what's the most likely token to come after that sentence, because it calculates which words are often seen together, and the token that has the highest probability gets selected with a particular probability. But it's probabilistic, so other tokens have a probability as well. And if that particular token has been seen in the data, then it will select that token. And so this probability makes it hallucinate and give you the wrong answer. So for example, let's take the example of Paris and France, and you ask it, what's the capital of France? It will tell you Paris. But maybe France, there's Lyon, another city, has been seen in particular kind of examples that were incorrectly because it's been trained on the data set from the internet, and some people might have given the wrong answer, and it's been trained on those wrong answers. So it's seen some wrong answers, and then it gives you the wrong answer as well. But this is not very related to our talk, so I guess I just wanted to mention that testing can also help you. How often does the model hallucinate? When does it hallucinate? When does it give you the wrong answer? And also with testing, we can answer questions around how do we ensure data privacy, and where does our model fail to protect the data? And so often those testing techniques, there's particular testing techniques that test the robustness of these LLMs. But there's, yeah.
Pause it for a moment.
Yes.
To bring it back to our discussion. So model has to be well trained on the large amount of the data. Suppose if I'm building LLM for the banking and financial, so I need to test with the large amount of data of banking terms and all those things, and mortgages, whatever it is. So in order to generate that one with the quality data, how you guys are going to generate the real-time data of banking?
Yeah.
How do you feed to the LLM to test it?
That's in one of my last slides where I talk about, so there's some, and these are very hard problems, and this is all things that we haven't solved yet, but there are particular ways you can address it. So the question was, well, if you have a model that's been trained on banking data, how do you then test it that it's actually giving you the right answer in that particular domain, right? In banking, or for you can have a model trained on medical data. Then how do you then test it to tell you what's the right answer? That's related to the Oracle problem, to the test Oracle problem. So the test Oracle problem, and it comes in my other slides, but let me address this a little bit. So in my opinion, I mean, we've had this test Oracle problem since testing was invented. So the test Oracle problem is, well, when you test the system, is the test input, and then the software runs, and then you've got the output. How do you know that the output is correct? And often we have exception handling and different kind of things in software to kind of tell us, so there's an exception. But often the failure can be due to some logical bug. So you need a human to look at it and tell you it's right or not wrong. So the human is the oracle, right? When it comes to the problem that you mentioned, so we've got a model that's been trained on banking data, and you ask it a question. For example, give me the list of people that got a loan application, from this year to that year. And so this LLM will go and summarize from documents and give you the list. And how do you know that's correct? So the output is the list of applicants, and then a human maybe needs to check. But how do we automate that? If we want to automate testing, we need to automate this checking the answer. And one way to do that is knowledge graphs. And so I will talk about that at the end, because so I think that's one of the ways that we've done, but there's other ways as well, and there's pros and cons. Okay, so quality assurance of LLMs. What are the different ways to do it? Testing is one of them, and we're going to talk about testing, testing is about ensuring that the software system is behaving as expected. I mean, this is the definition of testing and in general, but it's the same definition also when we're talking about GenAI applications or AI applications in general. The other ways that we can do it is benchmarks. And there's many benchmarks, and that could also be used to test that kind of system as well. So a benchmark is you've got a test input and you've got the expected output, correct output. And we call that the oracle, but also the ground truth. So given an input, what should the output be? And so these are usually static tests, and they usually are more useful for model selection, but can be gained. And they cover a particular space of the test inputs, but these are limited. So they're good, but if you use them on their own, they have gaps. The other one is LLM as a judge. There's a bit of a hype in industry about this. LLM as a judge is used. So what that means is you've got an LLM model or system, and it's giving you the answer. You give it a test input or a prompt, and it gives you the answer. And you have a second LLM that's telling you whether that answer is correct or not. That's been trained in a different way, with a different architecture, potentially with different data. So think you've got, for example, Gemini and Llama, and then you test Gemini, but you use Llama to check the answer.
The output will be passed to the other LLM that will get the information.
And you tell it, is this correct? And then it will tell you. But there's a lot of research actually showing that LLMs are very likely to agree with themselves. So if you tell it, well, an LLM generates an answer, this other LLM is very likely to agree with it, because LLMs are very agreeable things. And you can see from their answer as well, they know often kind of, if you ask it, depending how if you ask it, for example, I think that tomorrow is going to rain. I mean, I'm just making this up. Tomorrow is going to rain. What do you think? And it's very likely to agree with you because that's the way, I guess, it's similar to, if you remember the Google, this is a different topic, but in general, they've been made to agree so that they are likable. People can like those LLMs. And so they usually agree with what you tell them. So that's problematic. So in my view, testing is where I think is where we need to go. I mean, of course, we need benchmarks and LLMs, but there's a lot that we can do in testing to ensure the reliability of these systems. So why does it matter? Why should we do testing? And probably I won't stay a lot here, but if you have questions, happy to go deeper. But I guess testing is about ensuring compliance and mitigate risks. So there's a lot of regulations now, privacy laws, AI-specific guidelines. There's, legal repercussions if you deploy a particular AI system around privacy and so on. So how do you test that you actually are meeting these regulations? And there's a lot of work going on there. Address ethical concerns and ensure fairness. You probably have heard a lot about this, how these AI systems or GenAI systems have been trained on data generated by us, and we're biased. So these biases are, they learn these biases and even magnify them. So for example, and I should have taken some examples here, these biases are usually gender, ethnicity, country, age, There's many examples. I should have taken some here, but there's a lot of examples showing how these systems can be quite biased. And if you want to deploy them, there's going to be, you don't want it to behave like that. Toxicity is a big thing. So how do you test for toxicity? Toxicity is about your way you ask it. There's lots of examples, again, where these models, people actually asking people with mental health issues, asking for advice. And there's examples where these LLMs have recommended that they take their life, that they kind of, there's those kind of, or people asking for diet advice and giving advice that can be quite detrimental to their mental health and that sort of things. There's lots of examples around these toxic answers. And I'm not even starting to talk about, for example, people asking, how do I make a gun? And giving you the instructions of how you make it. And you've heard those things. And again, there are guardrails, but you can kind of circumvent those guardrails and so on. Again, you can test them for data privacy. So how do you evaluate whether, how they handle sensitive information? Do they give you passwords of things that, if you ask it to give you there was another case around this where you could ask it what's the password for the admin, and it would give you particular passwords and improve overall system quality and user experience. But so who needs testing? Well, testing also helps with how measuring performance over time, helps you reason when it's production ready, and how quantifying risk and reward, and also the sustainability, long-term sustainability. Now, types of testing, and probably don't know if it's this. I'll keep it high level. If you have questions, I can go deeper to those different types. But usually, we can think of the types of testing as black box, data box, and white box. Black box is when you just give an input, look at the output, you don't know how that output was created. You just have input and output. Data box, you have the data that's been used to train the model, so you can inform how you generate the input, because you can kind of look at, well, what does the what does the input most likely look like? And then you can use that to inform the input. White box is when you have the model as well. And then you can measure things like how well have I covered the different neuron activations, because these LLMs, they are deep learning models. They're based on deep learning. And so we have neurons and activations. And so we can measure things like, well, how well have I covered these neurons? And why is that important? In testing, we usually use coverage to tell us, well, we've got 100% coverage. But with LLMs and deep learning and machine learning, we don't have, it's not lines of code, it's neurons. So how do we know how well we've tested this model? Is through how one approach is to test how well we've covered the different pathways. It's not perfect, there's issues with that, but that's a possible, possible way of, measuring. It's a proxy of how well I've covered the different behaviors and whether any bugs exist or not. Okay, it's a bit of delay in loading, and I can't remember what the next slide is. Let me see. Oh, yeah. Which one is that? I might skip it since it's not loading. I just wanted to give you an example. Do you know Tay? Have you heard of Tay? No? Probably because Microsoft, really kind of, it just lasted for one day and they didn't want anybody to know about it. So they kind of hid it. What year was this? Was it 2016? So Tay was a chatbot, a natural language base, which is natural language processing was the precursor of large language models. Large language models, we became very popular in November 2021, was it then? When was ChatGPT?
I think 2022.
2022? Yes. So it was November, right? It was then,
Yeah.
2022. And before that, I mean, people were working on these, and there were chatbots that are basically based on natural language processing, which were the precursors of large language models. The difference that these large language models brought was this attention mechanism, which kind of really enhanced their capabilities. But I won't go there because I know that will be a long explanation. But I will just tell you a bit about Tay. So Tay was a chatbot that Microsoft developed that was a Twitter bot. So it was put in Twitter, had its own account, and it would interact with, just like we kind of users write things in Twitter. And she started really, I'm saying she because she looks like a she, but it's an it. And started with hello world, very kind things like see you soon, have a nice sleep, so many new beginners. So these are her first tweets. And in 24 hours, through interactions with users, then Tay started to learn a toxic behavior. And
Really 24 hours.
24 hours it took. And she started to say things like, for example, did the Holocaust happen? It was made up. Do you support genocide? I do indeed. And then there was another one, things around race, and there was things, and it's not all her tweets here, but there was also some sexist and misogynistic tweets as well. So the users manipulated Tay to become this completely thing that was not, and this is one of the things that can happen if we don't properly test and put guardrails around these GenAI. This is an example of, although it's not GenAI per se, because it was a precursor of it, but it can happen.
And this was in 2016.
Yeah, this was 2016. And there's other examples, more recent one, but I really like this one because it was, to me, this shows, what can go wrong in a very short amount of time. But also you probably have heard when ChatGPT was deployed, there were many other examples around, its behavior as well. So what I'm going to do now, and I think I'm out of time, but maybe I'll skip because I wanted to talk about bugs and how they are different. But I think we have only 2 minutes left, right? Vikas?
No, you can. We have time till 7.
Okay.
So we have almost,
Yeah. So maybe I'll skip this and I'll, share my slides because there's things. This tells you why these bugs are different to the normal bugs. And I might just talk about one of them, and then maybe the one that's related to, there's things to the non-deterministic behavior, the ecosymmetrics. Okay, I'm going to talk only one of them, the lack of ground truth, and then I'll happy to share the slides so you can kind of look at the others. So lack of ground truth when it comes to generative AI. So we talked a bit about the Oracle problem and ground truth. A ground truth is, well, I test it, I give a test input, it gives me the output, and we need, what's the right answer? The right answer is the ground truth, because we need to check it against the right answer to tell us whether there's a bug or not. And these are some examples of why this is problematic in GenAI. The first thing is AI bias. So if it gives us an answer, then it's not as straightforward to say whether that is biased or not, because bias is there are specific cases where we can measure bias, and if you're interested in this area, there's a lot of metrics that have been developed in this space. IBM 360 is one kind of suite of metrics for fairness, for measuring fairness, but they are mainly developed for traditional AI systems, not GenAI. GenAI is different because GenAI generates an answer that is completely new. It's in traditional AI, for example, when you have a system that you asked to tell you whether a loan application should be given to a particular person, and the answer is yes or no. So these answers, we expect those answers, right? It's classification system, so it's not a specific answer that we have seen before. Whereas with GenAI, it gives you a completely new answer, right? It's a text. When you think of ChatGPT, it creates a text that we have never seen before. And so if we've never seen something before, how can we automatically, we don't have a ground truth somewhere that we can automatically compare against. We need to look at it and reason about it as humans and think about, is it biased or not? And then bias, it's a concept that we can't, depending where you are, which culture you are from, which country you're from, bias can mean something different. And so this is quite difficult then to assess. Another issue is, so this is in general with AI in production. So when you have them in production and you want to do monitoring, you need to automatically check those answers. And these can be quite challenging. Think of Google Maps, for example, it gives you the shortest path. How do we automatically check whether that's correct or not? That's also challenging. And generative AI in general, how do we check that these new answers, that new outputs that are completely new and creative, how do we check automatically that they are correct or not? What I wanted to show you, because we're then I think we have run out of time, just some work that we've done. And also there's the papers there as well, but we've done some work around testing for fairness. And this was for some systems that were developed for hospitals, for the emergency departments. We built some AI models, and this wasn't generative AI, but there was AI models to predict the wait time of when you go to an emergency department. Usually, it's you're not told how long you're going to wait. I remember I went to the eye and ear hospital. I waited 7 hours, and I didn't know I was going to wait 7 hours. I mean, I had my computer, so I was working, but I had no idea, and I was and nobody tells you how long you're going to wait. So what we did here is we built a system that when you come in and you give your triage, they assign you a triage category and you give your information and so on. This AI system uses it to kind of tell you how long you're likely to wait. And so and this was in collaboration with 11 hospitals. And we're kind of, before deploying, we said, well, we need to test it. Is it actually, in particular, we looked at bias. Is it biased towards particular background? And we tested it for sensitive attributes. And what we call sensitive attributes, they are the protected attributes around in Australia, which cannot be used. I guess they kind of, how to say this? For example, when you're applying for a job, those attributes cannot be used, to kind of make a decision around whether you get like age, race, and so on, and gender, and so on. So we tested for those attributes. And what we found, for example, and this was a system that we built, that we trained, and it's not deployed in this form. But what we found is that that system was biased against almost all sensitive attributes, but in particular against Indigenous status. So it was predicting that the error in prediction was around 48 minutes. So it was predicting the wrong time by 48 minutes, which is quite significant, especially if you come with a particular, heart failure or something like that. Of course, then if we test and we identify the issue, then we can fix it. And so, yeah.
Was it because of lack of data, or?
That could be an issue because, yes, and that's a good point, because we didn't have a lot of data with Indigenous states. And then the model, it doesn't learn as well. So another work that I wanted to talk to you about, although this is work in progress, which addresses that question that you asked at the start. How do we test an LLM that's been fine-tuned for a particular domain, such as banking and so on? And we want to check, is it giving me the correct answer? And I think a very promising area, and one of my PhD students is working in this one, is what we can do is we've got all those kind of the knowledge, the domain knowledge, which is through documents and policies and procedures, and we've got past data, which this model has been trained on. We can build knowledge graphs. What a knowledge graph is a set of nodes and connections between nodes. A node can be, I take the example of France and Paris. France and Paris can be two nodes, and then the connection is capital of. So we can build these knowledge graphs on domain knowledge that we have for the banking system, for example. And then what we can do with this, we can automatically generate test cases which have the ground truth already attached to it. What does that mean? Is that I can ask, for example, what's the capital of France? And if the model tells me Paris, then I know from my knowledge graph that these two nodes are connected as capital of, and I can automatically check. But of course, you need to transform this into test cases, and we're building those approaches to do that transformation. But I think this is one of the most promising ways that we can do that kind of testing.
One more question. Generally, LLM developers, they do type with the banking system or medical system if they wanted to develop on particular area of domain. So they get the data from real-time data from them for test, or how you guys are going to generate with some test data generation tools kind of thing?
So can you repeat that real-time data?
While testing the LLMs,
Yeah.
the large data with a specific domain.
Yeah.
Suppose if I'm taking medical domain,
Yeah.
I need to feed a lot of data, right? So who will do you tie up with any hospital data to test these things? How do you
Get the data from hospitals, for example?
process it?
And it work. So it is a challenging thing, of course, because data,
Yeah, that's a very
it's really
challenging
hard
thing.
to
Testing
get.
the LLM.
Yeah. But I guess it's the same data that's been used, and I guess, and that's a problem also for the training and the fine tuning. You need the data is very important. It was one of the things that challenges for actually deploying this system. So data is important.
Yeah, because while we are testing an application on staging, in different environments, staging, production, kind of environments. So what we used to ask the production people to get the data, and we mask them, and we'll use the data to test the staging environment. So it's a basic, simple application while we are testing. Since it is a large LLM, right?
Yeah.
So we need a large amount of data. How that's a basic question.
Yeah.
So,
And how do you kind of convert that data into test cases as well that are?
Do you have any specific LLMs just for testing?
Yeah.
Oh.
So there's actually, and I'm not covering that here,
maybe we
but
can have a
but
offline
absolutely.
discussion.
There's quite a few, and one of my PhD students actually is kind of fine-tuning LLMs for testing. So we need to be, ChatGPT also is, if you give it a particular method and you tell it, generate me a test case, it will give you the test case. The problem is that most of them are incorrect, and you need to kind of, Copilot is also good for generating test cases, but there are also more specific models that have been fine-tuned and trained on specific testing data that may be a little bit better. But we have some work where we compare the different models and show which ones are better. And I'm happy to share that work with you as well. Yeah.
So aren't we building an AI based above AI, like AI would give an answer, and based on that answer, we'll be doing the testing. So aren't we building 2 years before processing the final answer?
Sorry, I didn't quite understand
so,
that.
You're from this architecture, you're saying that the input, let's say if I'm asking what's the capital,
Yeah.
it would give an answer, and then the another AI which we would be building would again examine and then give the data, right?
So that's one approach, and that's the LLM or AI as a judge. But I guess the knowledge graph, the difference between, a knowledge graphs are also a type of AI, but a knowledge graph, that the answer is correct. Another LLM might give you the wrong answer again, because they are probabilistic, whereas knowledge graphs are not probabilistic. You know exactly what it doesn't have a probability of France and another probability for another thing. It always gives you the right answer, right? So you can check it against the knowledge graph. But in a way, the way we do it, so we generate test cases from knowledge graphs. And that's more kind of, it gives you the assurance that it's correct. Whereas with another LLM or AI, 90% is correct, but maybe there's all that 10% as well. So if it's life critical application, then you still need a bit more rigorous approaches.
I don't quite understand. Maybe I'm thinking too simply, but why not build an AI based on the knowledge graph?
So I guess it depends what kind of AI as well. So if it's an LLM, then that LLM is probabilistic. So that LLM,
You can't merge the two.
you can, but that will be another kind of, you might,
Like if it goes like something like what's the capital of France, and that's more factual.
yeah.
And then it taps into the knowledge graph instead.
Yeah, but you might have also something like where Paris is also connected to, in the knowledge graph, it's also connected to, for example, London, and it could say, but the connection there says, I don't know, like I'm making this thing up, right? Flights from, right? But this LLM will not understand that these two things are different because they have this different relationship. It sees them as the concept of Paris and France is seen together, and Paris and London is seen together. And so then they are likely to, then when you ask Paris, then what's the probability that the next token is London, and what's the probability that the next token is France? It's kind of, and there's that probability because it's seen those concepts together. It cannot learn that relationship of capital of, right? So the LLMs are built on this concept of semantic similarity, which is concepts that are seen together in data. Then they are more likely to kind of be related in the LLM. So
in that picture, neural network comes into the picture to relate with that between two words and two tokens.
yeah,
And based on that, it will choose the outcome.
but yeah, so it is likely though that there will be another connection to another neuron that's not the right answer, but because it can learn that. I think there's a couple of more slides, but maybe we're done with time. But I wanted to just mention metamorphic testing. Do you know any metamorphic testing? So maybe that could be interesting, but I feel there's another thing that is useful for large language models as well to test them. Metamorphic testing is based on the concept of I have a test case X and I have the output of it that I know it's, I know whether it's correct or not, Fx. So metamorphic testing says that, well, if I transform this X to X prime, it defines this relationship so that when I transform X into X prime in a particular way, I will also be able to say how the answer will change. And maybe the answer doesn't change at all, or it changes in a particular way. I'll give you an example. For example, self-driving cars, it's an AI system. And we've got this image recognition system where it looks at a stop sign, and then it needs to press the brake. And so and then if it presses the brake, then correct, it's behaved as it should. A particular metamorphic relation is if I change the weather conditions, and if it's cloudy, or if I have, I guess, let's take the weather conditions. If I change the weather condition to cloudy, the image will change slightly, but it still needs to be recognized as a stop sign. So we can apply these metamorphic changes to the test cases, and I expect that the output should not change. But this is a very simple metamorphic relation, but there could be more complex ones, such as, for example, with Google Maps. A metamorphic relation, when I test it, is if I want to find the shortest route from A to B, and I find the shortest route, and I that's correct. If I move B further away, if I move the be closer to the initial point, the shortest route should be shorter than that first one. And so if it's not, then it's wrong. I know that wasn't a straightforward example, but I think this is a promising testing method.
So does it cause something like hypothetical? Suppose if car definitely want to hit someone,
Mm.
it has to hit a boy or a
Mm.
old woman.
Mm.
So how does?
I think that's
that is completely
that's a theoretical one. I think, yeah. I mean, that was that's a theoretical one, and probably that's it's interesting. There was a joke about this actually. So if you see a boy or an older person, who should you hit? And the person says, well, the older person because it's older. And then the guy says, no, you should hit the brakes. So, it's a hypothetical one. I know we've talked a lot about that because it's about, how do you implement these algorithms? But then how do you test for those? I mean, I guess the right answer is you shouldn't hit anyone, right? So, yeah, but it's an interesting one. I think I'll leave it here, but I think there's a lot happening here. So you're in the right space to work. It's a very exciting area. And yeah, hopefully that was clear. So thank you for it.
Let me see if anybody online has any questions.
This is Sanjeev here. Like, I just wanted to understand, like, how do we get started to work on this?
Hello.
Can you hear me?
Yes. You have any questions?
Yeah. Are you able to hear me? Okay.
Yes. Now we are able to hear you. Yep.
Yeah. I just wanted to understand, like, from our testing activities, right? Right now, we are still doing our day-to-day testing activities, be it functional or automation. But how do we get into this LLM or Gen AI testing side of it? Like, how do we start, like, even as a side project, or if you want to implement that in our office, how do we encourage our teams to start using or thinking around this?
So are you considering how to test LLMs or how to use LLMs to test?
Yeah. Both ways, like both.
Yeah. So in terms of how to use LLMs to test, the first starting point, I think, the easiest one is you can just use there's LLMs that are available, like ChatGPT, Gemini, Llama. They make their models available. So there's let me escape me. Hugging Face. There's a website called Hugging Face.
Yep.
And there you can find lots of LLMs that are made available. So Hugging Face. So people train their LLMs and also this big Llama and ChatGPT, and they make available those kind of a version of it, not the not the latest one, but one version before it. They make them available online, so you can access these models, and you can kind of you can fine tune them to your own data. You can do some prompt engineering, so you can try them how they work in terms of testing. And this Hugging Face will also have models that have particularly been fine-tuned for testing.
Yep.
But you can, so that's one, because I guess Copilot as well, you could use it, but the Copilot, you can use it as an API, and you can't manipulate it as much, but you can start. That's also another easy way to do it. How to test LLMs? I guess it's also, depending on what LLMs you're have in your own company. This is a little bit more challenging because you need to know what you're testing for. And so first you need to think about what are the things that you need to test for. I mean, if it's hallucinations, then you need to know, I guess, what the ground truth is. And you need to build, for example, you could do metamorphic testing. You can apply some metamorphic testing, which is, you could have some prompts and you can apply some minor changes to those prompts, and you don't want the answer to change if those changes are not major, and you don't expect your answer to change based on, for example, if you have what's the capital of France, or can you tell me the capital of France? These are two different prompts, but the answer should be the same. So you could do some sort of, but it's probably the entry point is a bit harder in that sense.
I mean, I think it's better if you unmute, because hello. And if you were asking something, you're on mute. You're muted here, so.
Oh, sorry. From my end, I think thanks for the information. I think that's helpful. I've started using Grok as a play area where like I'm sort of giving few in like some prompts. I'm still like sort of learning like how to give best prompts, but I think I found like Grok to be like very like it doesn't give me the exact scenarios, but at least it gives me a skeleton of the scenarios, a skeleton, and then I have to go my own homework and then do that. But thanks for the information for that.
Thanks, Sanjeev. There's one more question. What kind of skills should one develop for transitioning into GenAI testing?
Yeah, great question. I think some understanding of GenAI is it's good to have, not just for testing, but I think this is going to change also, I guess, other kinds of jobs as well. More and more, I think we will be interacting with these systems that have GenAI in them, and more tasks will be replaced with GenAI. So I think some understanding of what these things are, it's important so that we prepare for a future where it's going to be a lot more GenAI around us. So I think it's important to do that, but also for testing GenAI. Again, yes, some high level, I guess it's not needed to know exactly how the architectures are trained and built, but it would be useful to know what they can do and what are they capable, and in a way, high level how they do it, and what are some of the things that they don't do that well or not. So what could be, I guess, there's I'm trying to think. I mean, I do see from time to time seminars and conferences and around these things. In particular, the National AI Center. I don't know if you've heard about National AI Center. They do have training also for startups around Gen AI, but also for, in general for the public. But also at Monash, we have often public lectures and open seminars. We have a unit AI for everyone as well that introduces these things. Yeah, there's lots of different ways to do it, but yeah, good question. I think it's important to have some knowledge of generative AI.
Cool, awesome. Thank you. If there are no more questions, then we would like to thank Dr. Aldeida. Thank you so much for the presentation.
Thank you so much.
It was indeed a very wide topic, and then I'm glad that you touched upon very important points, which I'm sure opens up field for many more questions. So hence, it's a new field, and I know generative AI is answer to many things, but how do you test generative AI is a bigger question. So while many people think they are going to get out of jobs, especially testers, I would like to say there's a good news. You will be pushed hard for testing a lot of systems that are going to be out there. So yeah, please upgrade yourself and make sure that keep this circle intact. She's here with us. She's very much approachable on LinkedIn, and I'm happy to share her contact details if you need to. Just don't do spam calling to her. She's a very important person, and she took her time off and came all the way from Clayton, which is far away. So another big round of applause for that. During the peak hours, by the way. So really appreciate it.
No, thank you. It was a pleasure. I mean, it was a very lovely to be here and talk to you, and yeah, happy to have further discussions with you if interested.
Thank you.
Thank you.
Thank you, everybody. And that's it for today. If you have any questions, please reach out to myself or Aldeida on LinkedIn. And I'm sure you're missing being here in person. A lot of you did tell me that you'll join in person, but then you didn't. So we have some drink and some little bit of snacks sponsored by one of our team members. So you miss out on that. Please do come next time. And one last thing, now please subscribe us on YouTube, and that's where we are going to share this recording for. And also follow us on LinkedIn if you're not, because if you're part of the meetup group, then please do join. Cool. Thank you so much, and enjoy the rest of the evening. Take care. Bye bye.
Great. Thank you.
Yeah, I'll just say stop.